Swayam Prabha. Digital India. Educated India.
A very good morning, good afternoon, good evening my dear friends. Welcome to this TKM2 class or lecture number 2, and as you remember we had just started about giving a very brief introduction about general statistics, and we said that we will continue for 2 or 3 classes and then basically go into the depth of TKM and design of experiments. So, continuing the discussion further, we were discussing at length at the last fag end of the first class about probability mass distribution, probability density functions, and then the concept of, say for example, CDF values, cumulative distribution function of the less than type, greater than type, and how we could basically understand the CDF for the greater than type, less than type, considering that you are rolling a die and your main focus is to find out the CDF values for all the faces which are coming up less than equal to 4 or greater than 4. So, we will basically try to find out the concept and further concept, extend that for future discussion. Now, consider this, we have the following data related to the size and the number of 30 families in the city of Jaipur. So, they are basically 2, 6, 3 and goes to the last 2 numbers so on and so forth till 3 and 3. Now, the question is how do we represent the data using the tally numbers, frequencies and cumulative frequencies. The main focus is frequencies. So, these obviously we know, but I am not going to go into detail. So, you find the write the number of family members, write the tally numbers which is the second column. Then Fi is basically the frequency which I have been mentioning about time and again, frequency, relative frequency, chance and the probability in the long run. So, the frequencies are given in the third column, starting for number of family members with 2, the number is 3, then family number 3 is 7, family number of size 4 is 10, and the last one being family number with size 7 being 1. And if you find out the less than type or greater than type, then the corresponding addition of the frequencies are given. So, it basically starts, which is the second last column, starts from 3 to 30, and for the last column basically goes in the reverse direction, because you are trying to basically add up all the probabilities from the for the greater than type, and they basically come down from 30 to 1. So, if you draw the curves, you have the Ojai curves, if you remember we did in class 11, 12 and in statistics. So, the midpoint of the Ojai curves of the less than type, greater than type gives you the median, you can find out the median. This is just for information, and from there we can find out the other information. Now, guidelines for depicting frequency tables would be the classes should be mutually exclusive and exhaustive. The number of classes should be neither too small, too large. As far as practicable, the classes should be of equal length. So, that means when you are taking classes rather than any one number, consider that you want to find out the number of family members who have between 2 to 4 both inclusive. Then obviously, it can be either 2 members in the family, 3 members in the family, 4 members in the family. Then the next group would be 5, 6, 7 and so on and so forth. So, the class intervals are 3 and you do the problems accordingly. The following data represents the relates to the height in centimeters 40 individuals starting from 160.1 till 164.9. We are required to prepare a frequency distribution table, we are required to draw a histogram, we are required to draw the 2 Ojai curves. I am just reading the bullet points. So, you draw the frequency tables for the heights, the leftmost column are basically classes which have been made. One for the first interval is 145.95 to 152.95. So, obviously, the class intervals would be made in such a way that none of the values, any particular value rises at the end at the boundary. So, they have to be either in the interval 1 or interval 2. That means, I am considering them side by side. So, the values cannot lie between interval and interval 3 at the boundary, cannot lie between interval 3 and interval 4 and so on and so forth. So, the class intervals have to be made accordingly. Based on that, we have made these 6 intervals starting from 145.95, I am again repeating, till 152.95 and the last value being 180.95 to 187.95. The frequencies are given from 6 to 5, and this addition of the numbers in that class. Then the cumulative frequency less than type starts from 6 to 40, and the cumulative frequency from greater than type basically starts from the top to 40 to 5. So, if you basically draw the ogive curves, you will get the median and do the problems accordingly. To draw the cumulative frequency less than or greater than type, first specify the class intervals, then depict the class intervals along the horizontal axis, and cumulative frequencies less than or greater than whatever in the y axis. Against each class interval, mark the point by the corresponding cumulative frequency of the less than type or greater than type. Join the points depicting the cumulative frequencies, that gives you the ogive curves. Find their intersection, that gives you the median. So, this is the problem which you have solved. So, the black one where I am just now hovering. So, and this is the yellow colored highlighter which I am going. This basically gives the less than type, and where I am just hashing it marked. So, that is basically the less than type. So, now we will consider definitions of different measures, which are measures of central tendency, mean, then which is the arithmetic mean, geometric mean, harmonic mean, and then is the median, then is the mode, and measures of dispersions would be variance, standard deviation, skewness, kurtosis, and all these values. So, we will come to them as we proceed. So, for the mean, you can have arithmetic, geometric and harmonic. In the arithmetic mean, considering the probability of each occurring is 1 by n, considering there are n number of observations and each are distinct, and the distinct values are given by x1 to xn. So, the corresponding probabilities being multiplied by xi, I being 1 to n would be 1 by n. So, you basically technically add up all the values, divide by n and get the average. For the geometric mean, obviously you know you will multiply them, find out the nth power root and basically solve the problem. So, arithmetic mean may be related to height, geometric mean may be related to interest rate, harmonic mean may be related to the concept of speeds when you are traveling from city A to city B and coming back from city B to city A, you want to find out the average speed. So, harmonic mean is given by this formula. So, these we have solved many of these problems when we were small, as I said in class 11 or 12, or maybe in some of the schools they the boards they teach in 10 also. So, arithmetic mean, so this is the symbol which we use. This will become apparent time and again why we are using mu. Mu would be a general common variable used to denote the mean, whatever the distribution is. When estimating the long term expectation or random variable, the arithmetic mean is a natural choice. Finding the averages, age of the group of person, average income of a group of person, we use the arithmetic mean. So, for the harmonic mean, as I told you, consider a car travels between city distance x between city A N to B with first in the forward direction from A to B with velocity v1 and returns back with this and the same distance x from B to A and with the velocity v2. So, if you want to find out the average velocity, you can find it out as given in the formula. So, you see that you use the harmonic mean. For the case of harmonic mean, other examples are design for the stream of flow estimation for waste load allocation or estimation of effective petroleum and geophysical properties on the of a heterogeneous porous material. You will basically use the concepts of harmonic mean. For the geometric mean, suppose you have an investment which earns 10% in the first year, 50% in the second year, 30% in third year, and we are interested in finding an equivalent average return R. So, you basically find out if given P is the principal amount. So, the total amount of money which you get back after the first year, considering the interest rate is 0.1, would be P into 1 plus 0.1. So, that is 1 plus 0.1 in the bracket as shown here, where I am just hovering this pointer. Then it will be, if I take out that money again invest in the second year, it will be multiplied by the interest rate, corresponding interest rate of the second year, which is now 50%. So, it will be 1 plus 0.5, that will be multiplied by the first term, the money which you get back, and you basically go correspondingly. So, if I want to find out the average interest rate, it will be P into 1 plus R to the power n. So, here it is 3 years, so n will be 3 and you can find out R. So, which comes out to be 28.9. So, the median and the mode definitions, they would not be used so much in the design of experiments, but we will still define them for our own convenience. So, the median of a data set is the value below which lies half of the data, which means the probability is being divided at that point into 0.5, 0.5. To find out the median, we use this capital F, as we know, is basically the CDF value. So, the CDF value till that point, the sum of the probabilities till that point will be 0.5 or 50%, and mode will be given. The mode of a data set is the value that occurs most frequently. So, hence we will use the value as given, that the maximum number for which value the frequency or the relative frequency of the probability the highest, and we will find out that value as the mode. Mode may not be unique, it may be there can be more than one modes also. So, definitions of the variance, standard deviation and skewness are for dispersions, we will use these 3 terms, but mainly we will be using standard deviation or variance. So, variance is given by the expected value of the average of the square of the difference. So, in each term we take the difference between the realized value and the average value, square it up and add them, or you find out and multiply by the corresponding probabilities, or add them and divide by n, whatever it is, or in the case of continuous case it will be an integration. So, standard deviation will be the square root of that, and the skewness and kurtosis are given as the formula. They are just, I am giving you just for the interest rate, we will utilize that if at all required in the later cases. So, consider we have the following data points 5, 7, 10, 7, 10, 11, 3, 5, 5. From these data points we have mu value as 7, and then mu e as 10, mu naught as 5, and so on and so forth. So, based on that we find out sigma square comes out to be 6.89. Now, what is a random experiment? So, a random experiment is an experiment whose outcome cannot be predicted with certainty. So, consider you are rolling a die, or you are tossing a coin, or you are picking up chips from a box. So, in that case it is a random event, because we do not know what will be the value of the outcome. So, the random event or the random value or the random variable would be the case based on which you are doing the study, and the realized value would be the actual value of the random variable or the event. Sample space is the set of all possible outcomes of a random experiment, and sample points would be the elements of the sample space based on which you will try to find out how many sample points are, or they can be infinite also in the actual sense. While event is a subset of the sample space, as the collection of all the sample sets or points corresponding to the experiment which you are trying to basically find out. So, say for example, I am rolling a die. So, the sample points would be 1, 2, 3, 4, 5, 6. So, now if my event or an experiment is to find out the even number only, so the numbers coming out favorable would be 2, 4, 6. So, the collection of those sample points would be 2, 4, 6, based on which we will do our experiment, and we will define the event accordingly. So, probability. So, probability of an event is defined as a quantitative measure of uncertainty of the occurrence of the event. Objective probability basically would be defined on the game of chance, and which can be mathematically proved or verified. If the experiment is the same for 2 different persons, then the value of the objective probability would remain the same, it would not change. It is the limiting definition of the relative frequency, because if you remember, we are taking the chances of the relative frequency. In the long run, as I increase the number of observations, the sample points goes to infinity. So, that limiting ratio basically is the probability. Example can be the probability of getting the number 5 when we roll the fair die. Fair die means unbiased die. So, if you roll it, so the probability we know is 1 by 6, but actually it would happen, that is, you keep rolling them. In the numerator we will have the how many number of times the number 5 came, and in the denominator it will be the number of times we did the rolling or the experiments. So, subjective probability is based on the personal judgment, intuition and subjective criteria. Its value will change from person to person. Example, one person sees the chance of India winning a test series with Australia high while the other person sees it's low. So, obviously subjective. So, it cannot basically be based on the fact that there is some underlying very sound theoretical concept or mathematical concept based on which we can pass the judgment. For a random experiment, we denote the probability corresponding to the value when the random value is basically takes one sample point, and that sample point would have basically have a probability corresponding to that, which will be denoted by small p suffix I. So, obviously, if I collect all the probabilities for all the sample points, so it should be 1, that is point 1, which is basically given in the last bullet point where I am pointing my finger. And if I want to find out, say for example, any set A corresponding to the event E or A, so obviously it would mean that I add up all the probabilities for all the sample points which are under that set A and basically add it up and find out the probability. So, now here is what I mentioned here are the important points, I am just repeating it. So, probability of the sample point is Pi is the probability of occurrence of the sample point, whatever the ith one is, and Pi is the probability of the occurrence of that event corresponding to those case where you add up the probabilities of all the sample points which are a constituent assembly of the event. And obviously, the probability of the universal set, that is addition of all the sample points probabilities would definitely be 1, and for the null set obviously it would be 0. Suppose there are 2 dice each with faces 1, 2, 3, 4 till 6 and they are rolled simultaneously. So, there are 2 dice, this rolling in the 2 dice will constitute a random experiment. So, these the values of the universal set can be in the first roll you get a 1, in the second roll of the second die you get a 1. Other case can be in the first roll you get a 1, second roll you can get a 2. So, if you find out all the combination it will be 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. Now, if you basically go into the next stage, it will be I roll that first die, it comes a 2. So, corresponding to 2 you can have again from 1 to 6, then corresponding to 3 again you have basically 1 to 6, corresponding to 4, 4 means 2, 3, 4 I am basically meaning the outcome for the first die. To corresponding to 4 it will be again 1 to 6. So, this 1 to 6 are basically for the second die, then for 5 it is 1 to 6, 6 it is 1 to 6. So, if I basically find out all the combinations it will basically start, if you see the first bullet point from 1 1 to 6 6. So, 6 6 is here. So, if you want to denote the case that when you roll the die the 2 faces are same, that the total combinations corresponding to that experiment or event would be the set 1 1, that is 1 sample point, second one is 2 2, third is 3 3, fourth is 4 4, fifth is 5 5, sixth is 6 6. So, the collection of that event basically satisfies the experiment which we have done. So, you define the events in such a way that the outcomes for each die equal in one simultaneous row, then A would basically be, as I said, 1 1 to 6 6. So, if I want to find the probabilities, so each of them would basically be 1 by 36, because 1 by 6 is the probability of getting either 1 or 2 or 3 or 4 or 5 or 6 considering the unbiased die. Similarly, for the second one it is also 1 for all the values from 1 to 6, 1 by 6. So, if I find out the probabilities it will be 1 by 6 into 1 by 6, which is 1 by 36. So, I want to find out the probability of that getting for this experiment which I just defined, of getting the numbers coming out in the phase 1 of die 1 and phase of die 1 and phase of die 2 are equal. So, obviously, there are 6 events. So, it will be 6 by 36 and the whole probability would be 1 by 6. Second example is, suppose a coin is tossed repeatedly till the first head is obtained and we have the mu as the first head obtained, the value of the universal set is basically if I get the first head, so or if I get the first head in the second throw, if I get the first head in the third throw, if I just get the first head in the fourth throw, and so on and so forth. So, that means it can continue till infinity. So, the overall universal set would be the sample points would be H or TH or means sorry. So, it should be basically a combination of all the points. So, third point would be TTH, fourth point would be point means the sample points would be TTTH and continues till infinity. Now, if I want to basically find out the corresponding probabilities. So, I want to find out that we need to define an element that at most 3 tosses are needed to obtain the first head. So, 3 tosses at most needed being I get the head in the first, I get head in the second, I get head in the third. So, obviously, the probabilities would be in the first case for the sample point would be half, for the second sample point would be half into half, for the third sample point would be half into half into half. So, if you find out all the probabilities, it comes out to be 7 by 8. So, the classical definitions of probability defines that under this definition we consider the following: sample space is finite, all sample points are equally likely, that is they have equal probabilities of occurrence or equal relative frequency of occurrence, and based on that we basically define the problems. In a club, consider there are 10 members of whom 5 are Asians and the rest are Americans. A committee of 3 members have to be formed and these members are to be chosen randomly. Find the probability that there will be at least one Asian and at least one American in the community. The total number of cases would be 10 C2 and the number of cases favoring the formation of the committees would be given, like if there are at least one Asian and at least one American, the combination can be 2 Americans, 1 Asians and or 2 Asians and 1 American. So, the combination will be 5 C2 into 5 C1, that is the first case. That means, consider 2 American and 1 Asian, and the second case would be 1 American and 2 Asian, again it will be 5 C1 into 5 C2. So, the total probability comes out to be 100 by 120. So, the axiomatic definition probably says that under this definition we consider the following: sample space are infinite, sample points are not equally likely. So, if you remember the problem which we solved, like getting the first head. So, the sample points are W1, W2, small w1, small w2 till infinity, but the corresponding probabilities are different, because if I get the head the first time, the probability is half. If I get the head the second time, in the second throw it will be half into half. If I get the head in the third throw, it will be half into half into half, which is 1 by 2 cube, and I continues. Concentrate on that, it would mean that the probabilities are unequal and we can solve the problems considering them the axiomatic definition is true. Sample points are not equally likely, because that is what I said, that the probabilities are half, 1/4, 1/8 and correspondingly it goes on, and they are infinite because the when you will get the head we do not know. So, obviously, the set of sample points is infinite. Suppose we continue with example 2, where we have just discussed and we have defined the event B. So, that at least 5 tosses are needed to produce the first head. So, the sample space would be either a head, then is tail head, then is tail head and continues, and the sample points are, it is the head which is standalone in the first sample point, then the tail head is the second sample point, then tail head is the third sample point and continues. So, the corresponding probabilities are half, 1/4, 1/8 and then 1/16th, and if I want to find out at least 5 tosses are needed to produce the head. So, obviously, the head can come in the fifth toss. So, first 4 are tails, fifth is head, or the second one would be first 5 are head, sixth is tail, 5 are tail, sixth is head. Next would be first 6 are tails, seventh is head, and it continues till infinity. So, if I want to find this, it would be better if I subtract the particular value. What is that particular value? I will tell you. So, I basically I get the head the first time, the head the second time, head the third time. So, first, second, third, fourth, what I mean is basically I am getting in the first trial, second trial, third trial, fourth trial. So, I basically add these values and subtract this value from 1, I will basically get the answer. So, as is given 1 minus in the bracket P1 plus P2 plus P3 plus P4 would give me the answer. So, in theorems in probability is that for any event A and B being a member of the universal set, the probability of P on any event between is always between 0 and 1. If A is a subset or a proper subset of B, then the probability of A would definitely be less than equal to B, because probability cannot go negative. So, it has to basically increase. It can be 0. So, obviously, in that case PA is equal to PB. Then the concept of the union set. So, probability of A intersection B, PA would be plus PB would be basically intersection B would be PA plus PB minus the overall area common between A and B, and PA complement would be 1 minus PA. So, if it is a complementary set and A complement plus A is the universal set, then the probability of A would basically be 1 minus the probability of A complement or vice versa. Probability of a null set is 0 as given in the last point, and the probability of the universal set is 1. So, we will basically discuss now mutually exclusive. So, consider n events a1 to an, they are mutually exclusive if no two of them can occur together, which means pai intersection aj is equal to 0 for any I and j being a member of n. And mutually exclusive exhaustive would be considered an n events a1 to an, they are mutually exhaustive with at least one of them must occur, which means the union of A1 union A2 union A3 dot dot till A union AN would basically be 1. So, suppose a fair die with faces 1 to 6 are rolled, the universal set obviously would be 1 to 6. Let us define these events accordingly. So, A1 is given by 1 2. So, the sample points are 1 and 2, A2 is given by the sample points 3 4 5 6 separately, A3 is given by the sample points 3 and 5. So, if I basically look at A1 and A2 and A3, so I will basically can define the following: the events A2 and A3 are neither mutually exclusive and exhaustive, A1 and A3 are mutually exclusive but not exhaustive, A1, A2, A3 are not mutually exclusive but are exhaustive, and finally A1 and A2 are mutually exclusive and exhaustive. So, when you are coming to the concept of conditional probability, so let A and B be two events such that probability of B being greater than A is true. So, it is not a null set. Then the conditional probability of A given B would be given by, in the numerator you will have the probability of A intersection B, and in the denominator you will basically have PB. So, let me define this. So, assume the universal set is again the rolling of the dice, unbiased dice, and the numbers are, as I mentioned, is 1 to 6. So, and now I define events A as the even number 2 and B as the set of all the even numbers between 1 and 6, which is 2 4 6. So, if I find out the intersection of A and B, it is 2, and then if I find out that given B has occurred, what is the probability as the A B to occur is given by, if you note down where I am just now pointing my fingers, it will be 1 by 6, which is the probability of A intersection B, and the probability of B would be, there are 3 occurrences of the total 6. So, it will be 3 by 6 and the corresponding probability is 1 by 3. If I want to find out the probability of B given A has occurred, obviously it will be 1 by 6 by 1 by 6, because the moment A occurs, B has occurred. So, the Bayes theorem, let B1 to Bn be the mutually exclusive and exhaustive events such that PBI. So, there is the PBIs being greater than, all of them are not equal to 0, and for every 1 to n and define A to be an event. So, that is basically the conglomeration of the Bayes the conditional properties coming into the picture, which will be, if I consider the overall summation. So, that will make sense. That probability of A would basically be the summation of these n elements. What are those n elements? Probability of A intersection Bi divided by Pbi. So, I tends to 1 to n. So, what I have is basically, I find out the intersection of A and B1, that probability divided by the probability of B1 would be give me the first element. Next element which I will add would be probability of A intersection B2 divided by B2, and I continue and find out the sum which will give me A. And if I want to find the other way around, probability of Bj or Bi, whatever it is given A is given by this formula, which is basically the concept of conditional distribution on the Bayes theorem. So, with this I will end the second lecture and continue the discussion till we start the design of experiments. Have a nice day. Thank you.